Greetings. Let's talk about sketch constraints. So when you're in a part, if you're making a sketch and you're drawing, there's some things that you may or may not know about at this point. So I'm just going to draw a few items and we can talk about how to constrain them to make them not move around when tugged. The entire concept of Inventor is you are drawing with relationships in mind. It's a relationship-based modeling program. So when you're drawing things, it's one thing to size it, but you also have to worry about locations and locations for other sketches in reference to another, and so on. So, how do you go about getting those relationships in? Sometimes you can't put a dimension and, that be enough. So that's where, other items come in, like the constraints, and those are going to be basically literally relationships that you're applying to geometry, or eventually in later parts of Inventor you'll be doing it with assemblies as well, but this is purely sketch constraints. But it's just relationship to apply between stuff. So just to show kind of like how controlling these are, I can hit this tangent and put it on there, and it actually pulls the entire sketch piece all the way over there. And before I dive in too deep, the best way to tell if something is fully constrained is to click and hold and pull. And then as you can see, it moves, which means, it's not fully constrained. It's best to tug on points, but you can also tug on lines. The big difference there is if you tug on a point, it's actually going to be able to adjust more than just, this direction the line moves. So, if you're really trying to test something, it's best to grab a point, and then, in cases like these, grabbing the middle and holding and pulling, it just relocates it. So if any of y'all have taken any geometric dimensioning and tolerancing, you'll know that there's typically always like a location tolerance or a size tolerance, and those are going to be clearly they're a thing because location and size matter, but they're going to be what you're trying to lock in. So for instance, if I go in and I grab the circle and I move it to this point and let go, it's going to imply coincident constraints, and now when I pull it doesn't move. So now it's been located. So now the only thing that can change is the actual size. So once you have your size and location, the lines change color, and you're left with this. Basically now it's a fully constrained part. And if I were to go in and do the same and just generically move these items here, and I do want to point out, instead of grabbing and pulling and letting go, you can also hit this little button right here called coincident. It's the L-shaped one, and all it means is that you will make a point coincide with another point. You can also do a line. I could click this line, the center of it. As you see, the one cool part about a lot of these constraints is you get some other options. So I can choose the midpoint of this bottom line, and then click here. And basically the only thing you can change with both of these pieces now is to add dimensions on them. And after doing that, everything goes black, and this is where you can actually tell for sure if things are fully constrained, because now on the bottom right you see it shows fully constrained, and also the black lines are there, but the black lines are a little bit different. You can actually have lines that are just located, and it may not be fully constrained, but it'll show black. So using the color of the lines isn't like the end all be all for checking this. But besides the fully constrained down here and the colored lines, you can also check over here in the actual browser bar. You'll see you have a pin on your sketch, and when I hover, it shows fully constrained. So if I were to just undo one time, now you can see down here, well, first of all, you've got the blue line, it's clear sign, but you can see down here we see one dimension needed, and up here it no longer shows that pin, it just shows an open sketch. So basically you're just going to be trying to make sure that you always fully constrain every single sketch, and the reason for that is if I were to go and adjust something, say make this 1, everything stays in position, nothing breaks, but it can change in scale. So you know, it's a pretty powerful tool, but you got to know how to use it. And we're going to talk a little bit about that today. I'm just going to undo some of these being moved around. Okay, so, you know, down here you really don't have anything you need on the drop down, but you are going to be using this whole panel a lot. And, you know, you can mostly ignore these middle ones. There's this tool called Automatic Dimension and Constraints. It's terrible. You know, first and foremost, don't even bother with it. A lot of people, they try it whenever they're having problems, but if you're tugging on things, you know, doing the quote-unquote tug test, you know, you're going to eventually find your problem as you dimension and try to constrain it. So try to use that. If you use auto constrain, what's going to happen is it's just terrible. And basically it'll end up putting some kind of constraint or dimension that you can't hardly delete or you know, work with, and it's just not ideal. I know it sounds great in practice, but it's not in principle. So then yeah, we talked about coincident. You know, obviously I mentioned you can do a point to a point. You can also do a line to a point, stuff like that, you know, and then you can just keep doing it as many times as you need for whatever. I can even do, as you see, the end point to a circle. Basically you're just saying 2 points touch. And you know, technically you can do a point in a line or a point in a circle. So then the next one is collinear, and you know, you can hover over these to see more info like this, but basically it means that the two lines will become aligned, so they're in the same plane of existence. When I click this, they're going to become horizontally aligned basically. And I can do the same here. This is my actually favorite tool. You know, like, so one of the good perks of it is instead of trying to constrain things in one way, you can do it in another. So like I can actually say that these two are completely coincident by just saying collinear, but the difference is if I were to go in and you know, I'm going to add a coincident here to here. The difference is if I were to show the constraints by hitting this button down here, it's a show hide button. You can just toggle it, or you can hit the F keys. You see it's F8 and F9. But if I toggle it, oh, and also that button for showing constraints, I believe, is up here too. Yeah. But that one's only a show button. So this guy down here is going to be the king. But, you know, the perk of collinear is it's super easy to delete. I can just, you know, show everything, click on it, right click, hit delete. But coincidents are kind of hard, especially if you have multiple pieces of geometry. You know, that's what these corner points are basically, is a coincident. But the problem is that pretty much everything has multiple. So when you're starting to draw and you try to click and delete, and in this case it'd be fine. But what would happen is sometimes you may end up disconnecting your rectangle from itself instead of, you know, the corner to the rectangle or something like that. It's coincident is not user friendly. So that's why I am very opposed to it. And as you get better with Inventor, I'm hoping you will be too, you know. But basically, you know, that's the general practice is with collinear is you're trying to align things. And it's really useful. It depends on what you're doing, but obviously the ability to just horizontally align or vertically align, or just to say, you know, way up here and way down there, they're connected in alignment. It's great. So I'm going to offset another circle. And by default, whenever I move this circle, if you notice it stays together with this circle, this actually means that they are concentric. So basically, whenever you do an offset, it applies this by default. But I was hoping it would show constraints here. Maybe it's just baked in. I don't know. But basically, that's what we're going to do with a concentric constraint. You can choose two circles. And all it does, you can also use an arc. Let's do an arc. That'd be cool. They're all like the same exact size. There we go. So you can choose the concentric constraint, click on an arc or a circle and another one, and it makes them share the same center point. Now you still have to, you know, locate those circles, but you can go ahead and size them. And, you know, one little pro tip here, I could actually edit this and click on the other circle and then, you know, give numbers. So in this case, I'm going to do D1 plus 0.25. And there you go. You know, it's sized now. I love that you can always just click on another dimension and pull its info. But anyway, so then, you know, you just need to locate it. And as you can see, I'm tug testing. And then in a case like an arc, arcs are a pain. So then you still actually have to go in and locate where its rotation is. As you can see, it kind of flails. But yeah, concentric definitely has its uses. A lot of times you'll find when you're working with brackets and stuff like that, you always have a circle and a circle. You know, you'll have like radius 6, diameter 6, or actually diameter 12, but it depends on what it is. But basically, it's always like the same size. It is radius 6, diameter 6, yeah. And you'd end up with something like this, and you know, you'll be most likely using that a lot. Technically, you could not and just have like a center point coincident, and that would achieve the same result. But again, the perk of concentric is the ease of deleting constraints, which, you know, you'll refine with time, but it's a lot easier to delete this big old constraint right there. And you know, I wouldn't advise although I've got my constraints on, I actually wouldn't advise working with them visible, because what happens is when you try to tug your geometry, it doesn't let you actually, you know, on a rectangle in particular. But it basically, I pull on the constraints instead. So like when you're trying to tug test and it's not working, sure, you can tug here and that's fine, but you're probably gonna mess up, because what happens is sometimes you may not have your angle position in there. It may not know that this line is horizontal, which is what this constraint is. And you know, when you're tugging up and down, it doesn't move or try to rotate it. So if I were to pull this corner and this horizontal wasn't there, it may catch it, and it may actually pivot it around a little bit angularly. So I actually advise you to keep the constraint visibility off and tug on the points. So the next one I want to talk about is fix. And honestly, I do not encourage you use it at all. But it's nice for like kind of learning how things work and then deleting it after. Basically what it does is it allows you to lock anything in place. You know, so I could literally select, only deselect here. I can literally select everything and hit fix. Well, might be a little too much if I do it that way. There we go. I'll just select each piece. But like suddenly they're completely fully constrained, even though I have done nothing to them. This is terrible. I mean, you know, like that's cool that, you know, you can decide to lock things, but it no longer is a relationship based model if all you're doing is throwing in sketches and locking them. The only time that I would advise using this is if you say copy a drawing from AutoCAD and you don't need to change anything, and you are to never change it. And you know, basically when if you copy and paste a sketch from AutoCAD into Inventor, it comes in with 0 constraints. And to me, you should still go through and constrain everything and size it, because odds are, if it's that old, there's probably some changes needed and some false assumptions. So it's always good to go in and still constrain, in my opinion. But an application for fix would be to just basically paste something in and lock it, and don't mess with it because it's sacred or whatever, you know. But ideally, don't use fix. And you know, it is easy to delete. If you accidentally apply, you just delete the padlock, and that's it. But this is one of those things that if I see it, I'm definitely gonna ding it, that's for sure. And I still have one fix here, so I'm gonna delete that. So the next one is gonna be equals. Oh, I'm sorry, parallel. They always look the same. Obviously, equals the horizontal. So parallel, you know, anybody who's had math, they know what this means. It basically means that 2 lines are aligned. So if we look, we've already got parallels applied on each rectangle, you know, of course. So, you know, there's really not much to it. I'll draw some stuff over here. So basically, I take a line, I click it, I click another line, and boom, they're parallel. And this allows you to then, you know, slap in a dimension that is aligned perpendicular to each line, so that you can actually size it appropriately. Because, you know, if I were to have 2 lines that weren't parallel and dimension them in between them, you get an angle dimension. It looks fine at first, but then you pop it up and it says degrees, and you're like, oh crap, I screwed up. Now technically, I guess, yeah, you could type in 0 and then pull them apart and then you could put an aligned dimension, but that's just bad drafting. And see, it doesn't even let you actually. So, you know, basically, like, you're gonna have to, if you're working with angles, the way to position lines to where you can actually dimension between them is it's gonna be parallel. And then obviously when it's parallel, you can still reposition things. You're just working with angles. You know, it's pretty straightforward. Basically, if you don't have these parallels in here, what you get, let's do it on this one. You can also hit the delete key on these, by the way. What you end up getting, if I tug a point, is basically things can really start to break. Like if you see, this is all out of whack. Now granted, this bottom line, it still has a horizontal constraint on it. When you're drawing, you have inferred constraints, which is constraints the inventor understands that you need and applies them automatically. So that's why, you know, like obviously this rectangle that I did nothing to had 4 parallels and a horizontal. Well, and also a perpendicular here. You know, basically it knows that you need these, and those are the ones that it tends to default to are these right here. And you can always check your inferred constraints on the tools, application settings, sketch constraint settings, and then inference. And the default inference priority is parallel and perpendicular, which is great. You don't want horizontal, vertical. I can't imagine if it was slapping in all those. I tried it one time and I didn't like it. But anyways, so you know, a use case here basically for parallel is if you didn't have a rectangle but you decided you want one, you go in and add these back and, you know, just click the 2 lines basically, and there you go. Suddenly it knows that these lines are supposed to be where they are. You can also do the same thing with perpendicular, which again, if you're familiar with math, it means you're going to take 2 lines and form a 90-degree angle with them, basically. So, you know, like that's kind of what happened in the corner, but I could literally just choose all 4 corners. And there we go. Just like that, it popped into place. That's the fun thing about relationship-based modeling. You may have something that looks like total crap, and then you apply a few dimensions and suddenly it's perfect, and you're just like, what the heck? But it's all about an order of operations when you're doing a constraint or a dimension in reference to what else is left. If you do it out of order, you might not even be able to fix it without deleting constraints, but if you do it in the right order, it may just pop into place. So you know, this is one of those things you'll get with time. It's almost like a programming thing though, where you know you really got to execute tasks in a certain order. But say I didn't have this, you know, you would see basically everything is out of place now. That's where sometimes horizontal and vertical come in handy. And basically, you know, as you saw, it basically tied it in place. All it does is it says, you know, make a line horizontal. I can also do the same and say make a line vertical. And as you can see, and I actually didn't mention it, so let me turn this back on. This is perpendicular, in case you guys were wondering what that looks like. Basically, it's just like the symbol from, you know, math class, except for they added a little extra on the other side. So it's just a upside down T, or diagonal T. But your vertical and horizontal look the same, except for they are oriented different. So just look at the arrow end, I guess you call it, the one with the little feathers, and that's going to indicate the direction it's going. And they're very easy to delete, which is awesome. Now, technically, you could use these way more than you need to, and it would be bad, you know, but you could also use it in every area. But the problem with that is, you know, like basically if you ever decide this isn't going to be the way it is, you can't edit it. You basically have to delete every one of these constraints, because if this is not going to be, if it's going to be angled, you can't just roll with it, because these are, you know, based on these pieces. This is based on the actual grid, you know, so no matter what you do, you're going to have to delete these constraints if it goes angled. Whereas these, the lines are related to each other, so I could still go in, you know, delete that angle, I guess you'd call it a horizontal, and suddenly everything moves proportionally correct. But there is none of that with this guy. It's got to stay positioned to the grid. So this is why I really don't use a lot of horizontal and vertical either. The actual biggest use case I have for it, which is probably considered niche, but I love it. I use points with horizontal and vertical. I don't actually click lines. Maybe every once in a while I do. But basically, yeah, so like I could click this corner and the origin, and now it's, vertically aligned. And I will point out, for whatever reason, and this has been happening for years of Inventor, but it's still happening. For whatever reason, sometimes when you click horizontal or vertical, it may do the opposite command. So whenever you're doing this, make sure you're hovering first to see which way these lines are going. Sometimes you're going to be on horizontal and these lines will be vertical instead of horizontal, like it is right there. So, if you're not careful, it'll end up doing the exact opposite of what you want, and you'll probably be wondering why, and it's because Inventor just bugs out. But I'm going to do the same thing with horizontal. And just like this, what I've done is pretty much made this corner coincident to the origin, except I can actually delete this without, ruining all kinds of existing geometry. It's really easy to go in and delete those horizontal and verticals. So, now I can just tug this guy out. It's kind of a pain when you got pieces on pieces, but now it's disconnected again really simply. So that's my biggest use case, and it can apply to anything. You could have like a circle that's going to be up here, and you've got this piece, and I could just say that, this corner is going to be aligned with this piece, and then, I'm going to have a tangent here or something, and yeah, I mean, it definitely, that's the best application for it in my opinion. So then next actually is tangent, speaking of. And what this means is you're going to take a circle or an arc and make it perfectly connect to a line. So the general premise is, usually if you're doing a tangent, you're going to not need a full circle. You're going to have an arc of some sort. So what this allows is a seamless transition from the line to an arc, or vice versa. So if I were to go in and do a trim, well, obviously I need a ending over here. I'm just going to draw a line here. Delete this guy. Now you see I've got a perfect transition from the circle to the line. And that's the entire premise behind tangent. You're pretty much only going to use it for fillets, but you may find some use cases for it besides that. But you can also do a circle to a circle. And the same deal, if I had a line that went through all of this, I could trim half the circle, and you would basically have a fillet that transitions into a fillet. One more use case, which I kind of like this one, but say you had a rectangle that was equal in size. You could go and make if you don't know the location of the circle, but you know that it touches the corners all perfectly, you can choose each line. And just like that, it matches the size of the rectangle. So now they're, obviously tied together, and it got super gigantic. But, that's one cool use case for it too. But tangent's really straightforward. Obviously, basically you're probably going to be making a fillet if you're using a tangent. And I'm kind of willy-nilly about using actual fillet commands. They work. A lot of the times they work as intended just fine, but I tend to always just use a circle and then manually constrain it and trim it personally. This is my typical routine right here. Now granted, it's a little different when you got this geometry here, but the same concept still applies. Basically you just draw it in, trim it, and there's your round, just like that. It's, I guess that's really about it for that one. And then smooth. I never use smooth. I actually have nothing to report on it, but as you can see, basically what it does is it smoothens the spline arc. If anybody has a use case for this, you'll just have to let me know, because I've never once used it in my entire drafting career, so I have nothing to tell you. So the next one, let's see, is this still constrained over here? Cool, let's just get this out of the way. So the next one I want to talk about is symmetry. Symmetry is right up there with collinear. This is elite tier constraint. Basically, if you look there, it shows a 3 selection preview. What you're doing is you're choosing the left line, which is going to be to the left of a symmetry or center line, and then you see a right selection for the right line, and then you see the third selection is in fact that symmetry or center line. So what happens is it makes those lines the same relation to that center line. So if I were to go in and, well, I guess I could draw something like they did, but if I were to go in and draw just kind of like an L shape, which I don't know why it's snapping to a weird angle. Here we go. Wait for it. And I'm going to draw like a drastically larger one. And then I'm going to draw like part of it kind of slanted. Now I'm just going to draw a random center line. And for the sake of this, what I usually always do, and I would advise it to, is make it construction. So when you draw a line as construction, what happens is Inventor, when you're doing a feature, cannot recognize that as a line that is used for extrusions, revolves, whatever. So it'll just ignore it. So then this is literally purely for construction of the model, which is what you're wanting. I mean, that's literally the whole point is, to draw something as far as for relationships go. So now what I can do is click the first line, the second line, and the center. And if you notice now they share the same distance between the line and the line itself. And I can do the same thing with all of it. I can go in and choose. Now after you do the first one, it knows this is a center line. So after that, you only have to choose the two lines, and it applies that constraint, which you can see there. So I can keep doing this. And yeah, just like that, you've got it all. Now, at this point, like a part like this, what I would then do is go in and do a collinear, and a collinear, and a collinear. Now, you could also do, instead of the collinears, you could do some equals in there, but at some point, you still have to align them. So, like, I would have needed that top collinear. Whoops, I went too far. I would need that top collinear, and then I could go and say, this line equals this line, and this one equals this one, and that would achieve the same goal too. And as you see, when I pull, they adjust together. They're literally sharing symmetry and sizing. But that's the cool part about constraints, is you can do things in so many different ways. But obviously, the one thing I will say, although this is out in space, you would want this line to be sized. So what I usually do, because I'm petty, is I will use a horizontal constraint and just make it the same size as the profile, because that way you don't have to worry about giving it dimension. It's pretty basic, but just a simple horizontal here makes that line shared with this. So if I grow this, it grows too. I think it's a cleaner look, of course, but it all depends what you're going for. And yeah, I mean, that's pretty much it for that one. We already talked about equals, but let's talk a little bit more about it now. As you can see, it makes two things the same size. And ironically, I'm also going to use a circle for my first demonstration here. So if I were to click two items, it makes them equal. Pretty straightforward. You saw that over here. And that's really all there is to it. Anytime you're modeling something up, and that, say you have, say I drew in 1,000,000 arcs right here, and I was going to add in my fillets, okay? And I'm not using the fillet command because, basically the reason I don't is, like I said, it can mess up. But say you were filling the same way, you could go through, add in 1,000,000 of these, and then just dimension one. And then you're just casually going through and saying this one equals this one. This one equals this one, and so on. Literally just setting them all to be the same size. And that saves you from having like 12 dimensions, which is obviously a pain. And you don't even necessarily know why it's a pain, besides the fact that it's hard to edit. Because obviously if I change this to 0.1, they all grow, and that's nice, instead of having to change each one. But later, when you get really good at Inventor, there's the parameters area, and this value is editable there. So if you have like 12 dimensions and you edit them in there individually, it's going to be horrible. You're going to get real tired of it real quick. So trying to minimize the amount of dimensions to draw the part correctly is the goal. It's the idea of work smarter, not harder. So, basically try to set things to equal where they can be. That's the general goal. And, yeah, so make sure, that you're fully constraining things. As you can see here from this mess, I would need 48 dimensions to get everything done. But it's always possible. If you're having problems and you've drawn everything and it appears that everything is fully constrained, then it may be that you have a hidden piece of sketch geometry somewhere. It may be just a little smidge of a circle that you trimmed and you didn't see it, and it's just a little point. But whenever you look closer, it's actually there, an arc, and you can click it and delete it. So if you're having problems with finishing your constraints, that's probably it. There's probably some hidden geometry in there. But that's going to be it for sketch constraints. So if anybody has any questions, just let me know.